This is the third explainer in the series Zach Talks to You About AI, in which I, Zach, talk to you about AI. And this one is about a very often neglected topic, which is how do you measure the success of an AI or machine learning project for your business? There's some real subtleties here and some very tricky failure modes that are really important to try to overcome. So I'm going to talk about a problem that occurs when the leadership of the business outsources measurement of the success or failure to the AI or machine learning team. Right. So typically what happens is that leadership ends up taking a kind of naive approach. They recognize that machine learning projects exist to solve specific problems, and measuring how well something has solved a particular business problem seems like a pretty simple thing to set up. Right? You want to know, for instance, how accurate are the model's predictions? If the models are predicting something, how often is it right? You know, if they're predicting that you'll enjoy the movie, did you enjoy the movie? If they're predicting whether it's going to rain tomorrow, well, did it actually rain tomorrow? That seems simple. If they're a little bit more sophisticated than that, then they'll tie some KPI directly to the project. So they'll say not just that they want a model to predict X, but that they want the model to predict X having a certain improvement on a particular measurable KPI for the business. And it might seem that if you can do all of that correctly, then you're ready. You're ready to go. But in fact, it turns out measurement is actually just super, super tricky. I'm going to talk about an example here that is an absolutely real example that I got to witness close up for a company that does not exist anymore, as a matter of fact. But this was an online retail clothing company. And their business is selling clothing through the mail. And one of the things that they do that makes them popular with their customers is that they will allow customers to return any item they don't like free of charge. So what that means is that the company will lose money very quickly if customers return items. This seems like the kind of problem that's really amenable to a machine learning model, because what they can ask their team to do is to create a product recommendation system. And that product recommendation system is supposed to steer people toward items they don't want to return. There's a very simple KPI attached to this. It's just the percentage of items kept. They want that number to go up. If that number goes up, then they are no longer paying to have items returned to them. That's a major improvement in their business if they can get that KPI to improve. And furthermore, it has all sorts of other benefits. Presumably, if the customers are not returning items, then that means that they like the items more and they're getting more value out of it and they're more likely to stay. So this seems like a perfect problem. It, in fact, is a perfect problem for a machine learning team to be tasked with. Furthermore, this company has a lot going for it. First, they've invested over time and they've built a machine learning team that has plenty of smart people who are more than capable of solving a problem like this. Data is also not an issue. They've kept all their transaction data in a warehouse, and it is very high quality, it is consistent, it is easy to get to. It tracks every single item they've ever sold to every person, everything they've mailed, everything that was returned, prices, information on the products, information on the customers, everything. So that's great. Product recommendation systems, in addition, are really well understood things. In fact, if you start to look at tutorials for machine learning systems, you very often see product recommendation systems as the tutorial example. There's some very tried and true, very well-tested methods and types of models that work very well for this. So it's not like they're asking the machine learning team to do any kind of crazy original research or do something that seems like it's very high risk. It just isn't. Furthermore, they've successfully sidestepped a major stumbling block that a lot of companies face. A lot of companies will task their machine learning team with something and not have a clear sense of what KPIs, if any, they want that to improve or how they're going to measure the success of this project. But this company does that correctly. The KPI is very important to the company. It's easily addressed in a very straightforward way by this project, and it's something they can measure. So great. Furthermore, indeed, the team does develop the model in a reasonable amount of time. The model is pretty simple. It's not like these LLMs where it's expensive. It's very cheap to deploy. It passes every statistical test. The team sets up all of the tests of the model correctly and accurately. Then, at this point, the company also does something correctly that a lot of companies don't manage. Very often, the stumbling block for a company is that after a model is developed, and even after they're confident that it would help, they have some kind of technical or organizational problem that prevents them deploying it into their production environment and actually interacting with the business. But this company actually does that correctly. They've got good integration between the various engineering teams, and so the model is deployed to production right away, and it operates exactly as expected. And they start to measure the KPI, and the KPI improves immediately and dramatically. Unfortunately, there's going to be an unfortunately attached to this. The business has to turn off the model immediately because it causes them to lose so much money. I've seen the charts of the profits of this company, and there's a cliff that happens when this model gets turned on, even though it's improving the KPI. Why is this? Well, they did a kind of post-mortem and quickly realized what was going on. The model has noticed that people don't return socks. So this is an online clothing retailer, right? And people tend to keep socks that they buy. Socks are inexpensive relative to the rest of their inventory. And in fact, socks are loss leaders for the business. They lose a couple of dollars on each pair of socks, but it's okay because it encourages people to buy the pants and the shoes that go with the socks. Right? So the socks are loss leaders for the business, but that's not anywhere in the KPI. Right? The KPI is looking at each item in exactly the same way. So socks that aren't returned are the same to the model as a really expensive suit that's not returned. And so the model does its job. It recommends lots and lots of socks. The sales of socks just goes through the roof. But it burns money for the business. Now, why did this happen? This seems, on the one hand, like a kind of obvious problem that they should have been able to avoid, but it's easy to say that in retrospect. It's a lot harder to see that when you've been handed a problem that looks like it's precise and so reasonable and that you're so set up for success to solve it. It's really hard to see that some of your assumptions might be wrong. So what happened was that the machine learning team that was in charge of developing this model took that KPI, the percentage of items kept, and just ran with it. But that KPI had some unspoken assumptions. Right? ML teams, I think just as a matter of the psychology of people who end up on machine learning or AI teams or engineering teams in general, tend to assume that the business side of the organization will tell them what they need to know. They very often see their job as being on the technical side and that there's a line separating their work from the business side, and it's up to the business stakeholders to ensure that they are kept up to date and are well apprised on what they need to know. Right? We can argue about how much of that should or shouldn't be true, but I think that is a safe characterization of how people on machine learning teams do in fact tend to operate. And so what happened in this case is that the leadership gave their machine learning team a task. They attached a KPI to it. They gave them the resources. And then they said, effectively, don't bother us until you're done. Right? I once heard a C-level person say, well, that's no problem. We'll develop that. Well, how are you going to do that? Oh, it's okay. We'll just put the engineers in a room and lock the door, and we'll slide pizzas under the door until they're done. That's kind of what happened here. And it's a failure on both sides, right? The machine learning team didn't have any interest in the actual effect to the business so long as they did their job and affected the KPI correctly. And the leadership kind of assumed that all of these unspoken bits of information would just sort of magically be incorporated into the project. So how do you avoid this? Like I said, it's really easy to see this mistake in hindsight, but it's really hard to see it when you're actually working on a project and you're in the trenches. Well, the crucial difference between machine learning projects and a lot of other projects, for the sake of this discussion, is that we know for all sorts of engineering projects and product development in general that iteration is really important. But it's usually better to develop your product and then put it in front of people and get feedback on it immediately and change it, update it, apply lessons learned, and keep repeating that. And the faster you can do that, the better. Right? We all know that. What's special about machine learning projects is that you're not just iterating on the model and you're not just iterating on the product. Machine learning models often have unintended consequences, as was the case with the sock bot. And so it's really important to maintain that spirit of iterating, not just on the model, not just on the product, but on the actual criteria that you're using to measure whether the product is successful or not. Because these unintended consequences will cause you to learn more about that success criteria as you go along. I think I have literally never seen a machine learning project of any substance go from start to end while maintaining the same success criteria throughout the whole process. If it works, there's always some kind of tweak involved, an adjustment involved in that, sometimes major adjustments, sometimes small adjustments. Now, how do you do that iteration? How do you set up a situation where that iteration and updating of your success criteria is important? Well, you can't lock your machine learning team in a room and slide the pizzas under the door, even if that's what some of them might prefer. What you have to have is a regular feedback loop between your machine learning team and business stakeholders. Business stakeholders will tend to ask the questions about the impact of the models that the machine learning practitioners might not see. And so I very strongly suspect, there's no way to know for sure, of course, but I very strongly suspect that if there had been regular feedback between the machine learning group and the business stakeholders who kicked off this whole project for this clothing company, then they would have caught this problem months and months earlier. Someone surely from the business side would have said, so what do you think is going to be the overall impact of this on the business? Right? If one person had asked that, then they would have been able to catch the birth of Sockbot before it had an opportunity to do so much damage. And so when you're doing this, it's really important to have a frame of mind in which your formulation of the problem is permitted to change over time. You can't be wedded or committed to a specific set of success criteria and a specific definition of what you're trying to solve for a machine learning project without allowing that to evolve over time. So I guarantee that if you have a substantive machine learning project that's going to really make a difference to the business, what's going to happen is that you will learn more about your business as the project goes on. And so that requires a habit that needs to be consciously cultivated. It's a habit of zooming out. Don't get tunnel vision about specific metrics or specific KPIs. Those specific metrics and specific KPIs are really important. You need them, but you need more than them. You need to be able to zoom out and ask kind of globally about the overall impact of this project on the business, because this is machine learning projects tend to have tentacles that reach out across the business and impact it in ways that people might not foresee. All right, that's going to wrap up this one. Thanks. Comments are always read, as are and suggestions for improvements are always appreciated, as are suggestions for future topics.